Hello friends, welcome back to the continuation lecture on class 7, which is Introduction to NASTRAN. So far we have been seeing the NASTRAN inputs and outputs. So what are all the input files that is required for the solver, and what is the output file that is coming from the solver. And also we have been seeing the sample PDF file which I was showing to you, just to understand the various different sections of the NASTRAN file. So to give you a very quick recap, so patron, once the finite element has been modeled, it will generate a type of file which is called BDF file, in which the entire model will be written down in a statement format. We also call it as command format, or NASTRAN cards simply, which is a text editable file, which has the extension .bdf, that file, and then this will be submitted to the NASTRAN solver. This solver will solve this file, which is your model, and then it generates the output. So there are various different files which forms the output. F06 file is the primary file for all the results, forces, displacements, and those kind of values. And it also generates either one of these two files, which is xdb, or op2, which is the binary file that is important for post processing, which is generating the color plots, stress contour plots, displacement plots, etc. So we have seen that so far that NASTRAN BDF file, which is the NASTRAN input file, which is the BDF file, has five different sections, which are NASTRAN statement, file management section, executive control section, case control, and bulk data section. Now we'll be moving to something called delimiters. Delimiters are a small commands that indicates an ending of one section and starting of the other section. Suppose if I'll open the sample PDF which I was showing to you yesterday. So this is the PDF file. Over here, if you look at here, the cn command cn indicates that it is the ending of executive control section and beginning of case control section, and begin bulk indicates the beginning of bulk data section and ending of case control section. So any set of lines or any set of commands that goes from cn to begin bulk are considered to be the case control section, and anything from begin bulk to end data, the very last line of a PDF file will be end data, that indicates that it is the end of the model data. If I scroll, you can see, visualize, it's end data. So anything that goes from begin bulk to end data are the bulk data entries. So you can see there are node points, which is termed as grid, nodal finite element nodes, which we call it as grids in Patron terminology. This grids has written down all the nodes in a model along with its coordinates x, y, z, and this is the node ID. So each entry or each command within the PDF file has a set of predefined format. So each line has 80 character spaces, and each has many different fields. Suppose, for example, you take a quad element. Your quad element it represents quadrilateral element using C quad 4 with these letters, which is a string, and then it leaves certain spaces, and then finally it comes to printing the quadrilateral element ID, which is the numerical value or integer value, and then it will be the coordinate system, coordinate system ID, or the property ID, element property ID. It's one. It uh, and then space, again it prints the integer values, which are the node numbers, four corner nodes of this element. So going back to the slides, so we have seen the delimiters. So most in the most cases we'll see only three sections out of five section, which is executive case and bulk data section, and the remaining two NASTRAN statement and file management section will not be printed. So as I mentioned a few seconds back, each of the bulk data entries have a set of formats. So each line contains 80 character spaces, and similarly a bulk data entry can continue to multiple lines. So if I go back to the sample PDF, you can see now. So you can see that it has written down bar element. Similarly, there are some bar elements which continues onto the next line. Why this is happening is the user might have specified some extra parameters. You might have specified some extra material property, geometrical properties, or the section definitions, and that will be continued to the next line. And again, the format of the bulk data entries. When I say bulk data entries, those are all the model data, or those are all the lines within the bulk data section of the PDF file. Again, the format of the bulk data entries, or the format of the PDF, there are three types, which are small field format, large field format, and free field format. Whatever we have been seeing in the PDF is the large field format, and if it is the small field format, there won't be any spaces, and Patron automatically generates each field will be separated by commas, and free field format might be combination of both small and large. So for example, we'll take one element, which is the rod element, which is the simplest of all elements, which has two end nodes. So this rod element, the looking at the bulk data entry for this rod element, we know that it has two nodes. Each this will be the standard bulk data entry for the rod element. Each rod element will be denoted by its element ID, property ID, and then to which we create the properties, and then it will be referred by its two grid points, two node points. So as I mentioned earlier that each bulk data entry will have its own format depending on the parameters specified by the user. For example, if the same for the same rod element, if the user uses a higher order rod element which has mid-side nodes, there might be few other fields appearing. Or if the user specifies few other properties or parameters, then there might be the other fields which will be appearing on the PDF. So it completely purely depends on the user entry. So you can see the I have put down the snapshot from Patron how to create the rod elements and properties, just for the ease of understanding. So you create the select existing property or create a new property, and you can see the element ID list that will be appearing on the PDF. And then you create the property for the rod element and mention all the geometrical properties. And then for separately for the material properties, that will be separate. And this is the beam section or beam element property and library. how to create a beam element. So I'll be demonstrating at the towards the end of this lecture. So now moving to the bulk data entries, whatever I was speaking. If you look at this, this is again a sample BDF file. If you look at this BDF file, we have rod element and associated properties. So there are some rod elements. It looks like from the BDF I can understand that the model has three rod elements. The first set of integers are the element IDs, which is 1, 2, 3, and second set of integers are the property IDs. In this case, all the three elements have one single property, which is this one. And when I go into the property will have its own property ID, which is referred in the element CROD entry, bulk data entry, and then the property bulk data entry has the format of first one will be the prod, and second one will be the property ID, and third one will be the material ID. Material ID indicates one, so that will be material properties are cross referenced here within the bulk data entries. And then the last two digits are the uh, your grid points. So that means that C rod 1, which is the rod element 1, is between the nodal points. It has two nodes, node number 1 and node number 4, and rod element 2 has two nodes, which is 2 and 4, and rod element has 3 as 3 and 4. And all of these rod elements have one single common property. Property is the geometrical property, and material property will be created by the material card. And then all these grid points, all these four nodal points is written by grid point, grid card, grid bulk data entry, that will have the grid grid for first field will be the grid string, and second field will be the grid point ID, which is the integer value string, and third and fourth and fifth will be the x, y, z coordinates for the entries. And also it will be the, if you have any nodal constraints, that will be appearing towards the end of the grid point field. So before moving into the demonstration, I will show you. If I go into the sample BDF, you can see the grid point entry. It has node numbers and at the same time x, y, z coordinates. Now going back into the slides, we'll see demonstration in a minute. So before that, there are some few important NASTRAN commands for each of the sections. First one is the case control section. So on the case control section, you specify the particular load case. If I go into the sample BDF, so any BDF you open, C end indicates the end of executive control section and beginning of case control section, and begin bulk will be the starting of bulk data section. So whatever that goes between the C end and bulk data indicates the case control section. In this case, or in this BDF, or in this model, there is only one load case, which is the default load case. The user has created default load case. He has also requested displacement. He has also requested the constraint forces, and also he has requested the element stresses for all the elements within the model. So these are all the outputs the user has requested, and the name of the load case is the default load case. The user has created the default load case, and you can see from the executive control section, you can see the solution 101. He has run the linear static analysis. It also prints the naming. So solution 101 indicates NASTRAN solution 101 indicates that it is a linear static analysis. So going into the some of the important commands, you can see that from the output request, you can see displacement, you can see the force, which is the element force, and GP force is the grid point force, which is the nodal force, and O load indicates the applied loading, and SPC is the constraint force or the end reaction forces for the boundary conditions, and stress is the element stress, and strain is the element strain. So these are all the some of the important commands that you will be seeing in a case control section. And similarly, in a bulk data section, you can see the complete model. Obviously, it is the grids, quads, triads, and everything. Apart from that, you will also see the param commands. Param commands play a specific role. Like when the user specifies param post -1, that means it indicates the type of the post processing file that it needs to generate once the solver solves the PDF. So param post -1 would generate OP2 file, and param auto SPC no will remove any automatic constraints. Param weight mass 1 will be the weight mass conversion factor. If I go into the PDF, you can see there are many different param commands that play an important role within the NASTRAN PDF file. So that will, based on this, the model will be analyzed. So param post, each one will have a specific meaning. Param post will generate the type of file, whether it is an XDB or OP2. And at the minute, just forget param patwa. I will explain you later in the demonstration. So param auto SPCS is like you are making the pattern to generate automatic constraints. Mostly the user should specify auto SPC no. That indicates that we are asking pattern not to use any automatic constraints if the model is not able to be solved. And then param cup mass 0, that means in the finite element technique, there are like coupled mass and lumped mass uh, for the stiffness matrix calculation. So we are using coupled mass method for your stiffness matrix calculation. And param K6 rot is the rotation on the drilling degrees of freedom, which is the out of plane perpendicular rotation of the elements. We say 0, that means don't use any rotation. And param weight mass 1, which is the weight mass conversion as 1. Param no comps -1 will be, we are we are specifying that we definitely need the composite element stresses for the composite type of stresses for the composite failure criteria, such as if the user has modeled the if he has used composites within the model, and if he has specified some composite failure criterion such as soy hill or soy who, then he is extracting those results. Param cup mass -1, sorry, param no comps -1. So each will have a specific meaning, but you might ask how to know and where to know these whole things. Like one of the best reference would be the NASTRAN reference manual, which has thousands of commands for each of the specific analysis. As we go through the rest of the course, I'll be showing you various different things on the NASTRAN PDF. So that will be really helpful for you to understand much more clearer in a better way. So first, I'll be demonstrating the we'll create a plate with a stiffener, and then I'll demonstrate you various different parameters that we need to specify to create the PDF file. And we'll also, once the model as Patron generates the PDF file, we'll open the PDF file and we'll dig into that